webinar of this technical session in the summer. I hope, although it is summer, so we expect some holidays this time of the year, but I hope this session will be useful for you, and also you can rewatch it if you cannot make it for the further webinars in the future, in the next weeks. Okay, so because this is our first webinar, I will start with a general introduction about Huawei, and then we go into a bit more details regarding the 185 KTL inverter. So we will see some technical specification that we would like to share with you. And in the upcoming webinars, as you might have seen, the topics we will go into more details regarding string design, how to optimize the string design, what is the smart IV curve diagnosis system, how it works, what does it do, what it does, and also like anti-PID solutions, what we can provide in case that is a problem for the customer or for some project. Okay, so as Huawei, we are an information and computer technology company. We have more than 194,000 people all around the world in the globe. We are operating in more than 170 countries. Half of our employees are involved in the R&D segment, so they are continuously making our solutions better and better. We are in the Fortune Global 500 as a 61st company. So this is about Huawei in general. Our last year revenue was $123 million US dollar. This was a more than 19% increase year to year. So it is very prospecting. It was very prospecting, and we hope this year will also similar. Our main known products, I can say, this 5G base station, the smartphone shipments all around the globe, and also switching stations like computer stations, and also big data computing. As we believe the investment into the R&D is driving the company further and further. We yearly invest more than 10% of our revenue into our R&D, based on a measurement done in 2018. We were the fifth largest industry company who is investing high amount of money into R&D. And this R&D resulted in, for example, the first 5G chipset, or the first AI-powered solar module diagnosis, which is the smart IV curve, which we are very proud of at the moment. And now to the solar industry. So we see a growing potential in the string inverters, and also the interest from the market is headed to the string inverters. As you can see, it was started from 2016. It was only just 38% of the market, but now, as of last year, it was more than 57% of the global shipments regarding string and central inverter. And as of end of last year, we have been the fifth largest global player in the inverter segment based on shipment, and we hope it will continue this year also. So as Huawei, we have solutions for every kind of markets, like residential, where the prosumers consume electricity and they also produce electricity in a smaller degree. Commercial and industry, where the consumption happens mostly at the same time when the power is generated, and there is a utility where the generation happens far away from the consumption, and it is transferred via high voltage lines to the consumers. So now just a few outlook in the energy sector, what we expect in the future. As in the past years, we see that the PV investment, the PV installation is growing, but there was also other carbon fuel investments all around the world. But we see that the decarbonization is happening at this very moment. So in the future, we expect higher penetration of PV and wind power. So it will happen in the end, and also the LCOE, so the cost of electricity, the levelized cost of electricity is going lower and lower by each year for the PV industry. So it will be more cheap. It will be cheaper to invest in this segment and to generate power with this solution. And as I mentioned, the string inverter is heading, the market is heading to the string inverter business, and we also see a surge in the bifacial modules applications all around the world globally, and also a tracking system is becoming more and more popular. So one of our main concerns as a market player who oversees the whole world, and then see what is the trend and what is the concern coming from grid operators, is that there are this so-called weak grid, which may cause problem in the long term if the PV penetration will be too high. And this is the reason why we think that this will be one of the driving point of the PV segment to achieve similar characteristic like the ones those generators which has spinning reserve, like the gas turbines and the steam turbines. So this will be a challenge in the future to support the V-grid even in not very good conditions. Okay, so let's start with the 185 inverter. Our solution and our picture about the utility segment is that we provide a string inverter to the customer with the whole package with a smart array controller, so with a management system included, which can be Netico system, and there will be a seamless integration between the bifacial plus trackers and the transformer station and our smart array controller. So by this way you can achieve higher yields, smarter operation and maintenance, and a safe and reliable operation. So the 185 KTL inverter, as you may have seen, it has a maximum efficiency of 99.03%. So this is the maximum efficiency it can achieve. The European standardized efficiency is 98.69%. It has 9 MPPTs. It has 9 MPPTs, as you can see here, and each MPPT has 2 strings. So in total, 18 strings can be connected. There is 18 inputs to connect. The power point tracking system voltage range is between 500 and 1500 watts. The maximum amp is 26 amp for each MPPT. The short circuit current for each MPPT is 40 amps, and we have the DCs which is included, 3 of them on the DC side. We have type 2 on AC and DC side, type 2 SPDs, so surge protection devices. The nominal active power of this device is up to 40%, it's 175 kilowatt, and up to 45% it's 168 kilowatt, and up to 50% is 160 kilowatt. So regarding the thermal design of the inverter, it is a fully sealed design. So as you can see, the air enters here via the densely holed ventilation plate. It will go through a numerous air duct, and it will be driven to cool down the whole device. We have 3 fans included in the system. This will give us a higher flow of air in the to circulate. This fan is removable. It can be exchanged or can be replaced if anything happens. But this is certified, and this is designed to reach the operation life cycle of the inverter. So there is no regular maintenance needed on the fan. And one of the design concept is that the upper side of the inverter is there is no hose, so nothing can fall inside the inverter's cooling chamber. So it means no leaves and no materials or residue can build up on the upper side of the inverter. The air can only exit through these 2 ventilation plates on the on the left and the right hand side. So this is how we can guarantee the cleanliness of the inverter and the maintenance freeness of the inverter. Okay, so as I mentioned, it is a fully cell device. So it's the IP rating is IP66. This way we can make sure that the operation goes smoothly all along the whole lifetime of the inverter. So this is just introduction, front view of the inverter. So we have the side view, as these are the air outlets. So the air exits through this densely whole the ventilation plate. The back view of the inverter, as you can see, there is no openings also to the back and also on the upper side of the inverter. And we have the bottom view, which includes the DC, the MC4 connections, which is categorized into 3 parts based on the 3 DC connector, this connector. So, and also we have the AC connection right here, which is also can be viewed here. It is an you can open this door, and you can insert the AC cables, and also if you want an RS485 cable. So about installation, it can be installed vertically or it can be installed horizontally if you keep this 15% degree of tilt. So this is the maximum that the inverter can accept and can work accordingly. So this should be maintained all the way. And the reason that we can do is that we have the fan in the inverter, so it can do horizontal operation also. You have to make sure that you have enough space during the installation. Like for the above the inverter, we need 200 millimeters just to have the inverter enough space. And also on the right and the left hand side, for any kind of maintenance or easy access, we have to leave 600 millimeters, and also for the air to come out, the warm air to come out. And also below the inverter, we advise to keep at least 600 millimeters, just in case there will be some snow, or not in the south part of Europe, of course, but there is some grass growing, so it doesn't interfere with the inverter. It's better to have these kind of clearances. So as I mentioned, one of the key aspects of the inverters is to have a kind of grid support. And the inverter has the ability to support reactive power to the system in case of there is some faults or there is disturbances on the voltage. So the apparent power, the rated apparent power is 185 kilowatt, although the rated active power is 175 kilowatt, but it can do also 185 kilowatt at cosinus V1, and so it is able to operate at that high power level. And the maximum reactive power that it can output is 111 kilowatt, which is the 60% of the apparent power. And by this way, and the functions that are included via software, the inverter can support V-grid. V-grid can be defined as the short circuit short circuit ratio of 1.5%, 1.5 ratio. So these functions which are included in the inverter is it has an advanced algorithm to control and to sense what is happening in the grid. So in case it detects some fault, it has the capability and the ability to ride through the fault and to support the grid. It has total harmonic distortion below 1%. It has, as I mentioned, fault ride through capability, and it can support the grid up to 1.5 SCR, which is the short circuit ratio. And these software modulated functions are like virtual impedance calibration, virtual active power filter, or FRT, recovery spike suppression. So this is a fault right to recovery spike suppression. These are all the functions which help to establish a safe and good operation for the grid. Because in the last years we have seen that the grid operators were not keen on implementing the decarbonized power like wind and like solar, but especially solar because it doesn't have that spinning reserve. So by this way, by adding these functions into the inverter has to stay online in case there is some fault in the system. So it should not and must not switch off, because this way the power can be even higher than it was before. So this way, by keeping the inverter online, the system and the grid can be more stable on the long run. So you might have heard and you might have already experienced the potential induced degradation. This potential induced degradation is coming from the fact that the whole system is connected to the ground, except the PV module cells, which are double insulated. So due to the potential differences between the PV module cells and the aluminum frame of the mounting system, there can be some degradation of the panel due to the force which is driven by the potential difference. As you can see here, if we have a system, a DC one string connected, at the beginning of the string we have a negative voltage, so it is below zero. At the middle point we have voltage difference, so potential difference between the cell and the frame equals zero. As we go to the positive side, we will have positive voltage difference. Due to the construction and due to the fundamental of PV cells, or at least most of the PV cells, has problem on the negative side. So it means that the closer you are to the negative side, you will have this kind of degradation of the cells. Um, this is coming from the fact that there are the sodium ions which will go into the cells, so it will degrade the cells due to this force, which is driven by the potential difference of the frame and the cell. So this is one of the key factor which affects the power of the panel. So if you install a PV panel and you start the operation, let's say it has 100% power, this is the only moment and this is the last moment that it will have this kind of power. As soon as you start the operation and you will check it one year later, you will definitely have less than 100% power. So this is on the long run, if you operate or if you want to operate a power plant for 25 years, you must take this into account, and you can mitigate this kind of problem. And the mitigation happens if you switch and if you offset this negative voltage above zero. So the whole system will be above zero, so there will be no potential differences, no negative potential differences between the cells and the frame. So this is done in our system. Just a short introduction, as it will be a different topic in the future, in the next coming weeks. That we have a separate NT-PID module connected on the AC side next to each transformer station. So for each transformer station, you only need to use one this kind of PID module, NT-PID module. And due to the fact that this is placed outside of the inverter, not on the DC side, so it is on the AC side, we have personal protection included. So all the voltage that is applied to the AC side will go through the inverter. As soon as somebody will go on the site and touch the inverter, not the inverter, touch some conductive element which is live, and there will be some current leaking through the person. This can be detected by the built-in RCD. So this makes our system safe to use in every kind of scenario. So this NT-PID module works, as I mentioned, on the AC side, and due to the fact that the DC bustling voltage has a direct connection between the AC neutral virtual neutral point and phase voltage. So between the phase and this virtual neutral point, the voltage will be the same as the 0 point of the DC bus link, and for example the positive point of the DC bus link. So as long as you control this virtual point and you raise the virtual point of this AC side, the PV voltage will be also offset. So we can raise the PV voltage, the DC voltage, via this way. And the how we can do is, as we apply a DC voltage on the AC side, and this DC voltage equals just around 750 volts. So this way we can make the system above zero. So we might get these questions a lot. What kind of cable should be used? What is the cable requirements of this PID operation? So as you have seen, the phase-to-phase voltage doesn't change. So between phases there will be no changes of voltage. But due to the fact that we add this offset voltage on the AC side, there will be increased voltage between the phase and the PE. So it can be calculated via this formula. So the phase to PE voltage will be 906 voltage at worst case. So it means that our cable should withstand this kind of voltage. We have checked with many cable suppliers, and the 1/1 kilowatt standard cable meets these requirements. Although some cable suppliers say that the 0.6/1 kilowatt cable also meets this requirement, but this should be decided case by case by the developer or the installer, or the one or the designer who is responsible for this. But for sure, the 1/1 kilowatt cable meets this requirement. And one important factor is that if you're using, or if you want to add NT-PID module, you have to use IT earthing system. So the neutral point of the transformer station should be isolated. Okay, so some cable guidelines. What we have seen in the worldwide operation is that many of the EPCs, like in India or in other Asian countries, we have seen that in order to cut the cost of the cables, they will divide the area into three segments, into three stage. So by this way, they can differentiate the cable sizes between these sections, and they don't want to use, for example, the 120 square millimeter cable for the whole system, because it can raise the cost on the long when they start a project. But they are okay if they are having a smaller cable closer to the transformer station. So by keeping the voltage the voltage at the expected level, and the AC losses at the expected level, they can invest, and they can have this new solution to have this three stage the area. So by this way, they can cut down the cable costs. So in case you are looking for some capex saving, this is one of the options to use. So the cables that can go into the 185 inverter, we have the option to have a single core inverter, multi-core inverter, which means one inverter consists multiple cables. And these so for the multi-core cable, the between 70 and 185 square millimeter cable is accepted, and also the diameter limit should be followed. So the maximum diameter with the insulation included is the maximum 66 millimeter, but it can be chosen the whatever cable glands the customer or the installer requires, so it can be adjusted. And also one important factor is the neutral cable cannot be connected to the 185KTL inverter due to the fact that these inverters usually operate in a utility system, and in the utility system, the whole system does not require the neutral cable to be there. There are no houses, or there are no other consumers or electrical devices which might require the neutral cable. And also we have the AC and DC cable recommendation. It is just a recommendation. Anyone can choose similar cables with similar characteristic. So it should not be this. There's no problem. It's not the same. But for DC cables, there is the option to have the 4 square millimeters or the 6 square millimeters connection. And as I mentioned, you have the option to connect a copper or aluminum cable with the relevant cable lug to avoid any corrosion, electrical corrosion. So you can connect from 70 square millimeters up to 185 square meters for the multi-core vertical cable. And if you go back, we can see that for the single core cable, we can connect up to 240 square millimeter cable. And we also get the questions regarding how long should be a string, or how it is, what is the better for the inverter. So if somebody comes with a central inverter background, it might for the central inverters, usually the maximum power point efficiency is at lower DC voltage than it is for string inverters. As you can see from this picture, the above, so the highest line, so the highest efficiency comes at 875 volts. So it means that the cable, it means that the PV string length should be calculated accordingly. But if you go above this, you will have some kind of loss because the whole system will be operating above the maximum power point, so it will be lost in the long run. With our string inverters, the maximum power point efficiency is at around 1,200 watt DC, as you can see here. It is just below 1,200 watt DC. So it is always advisable to use as long string cable and as many PV panels as you can. So by this way, in most of the time, because in most of the time the DC voltage will be not close to the open circuit voltage, but it will be close to the maximum point of the whole system, maximum power point of the whole system. So it's better to use as many panel as you can. But this will be also a topic of the further technical session, how to configure it, what we advise to use regarding open circuit voltage calculation, how we can take into account the temperature or the PV panel, the temperature of the PV panel. So we will go into the details in the next weeks. And in case you would like to connect higher DC-AC ratio, or you have a low powered PV panel, which way you will achieve, or which way you will succeed, or go above the open circuit voltage limit of the inverter, it's advisable to use this Y connector. This Y connector makes the possibility to connect one extra string for one MPPT. So as I mentioned, each MPPT has two string inputs, but for one input you can have one extra above the one, so it will be in total three inputs. Due to the standard and due to the PV panel manufacturing, in this case, if we are using three strings for one MPPT, we must include a fuse. This is the reason that the PV panel cannot withstand a short circuit from three strings when there is a problem in one of the strings. But for two strings, the standard makes us make it possible to not use any fuses. But as I mentioned, for this case, you have to use fuses. And this Y connector is it comes in a package. Usually, we can also supply it, and this is look like this. There is a positive side. You have the positive fuses included. This is the Y connector itself, and we have on the negative side also another Y connector without the fuses. And on the third string, which will be the third string connected to the second input, will also have a fuse because it is connected to the same MPPT. So it must include fuse on the positive side. But on the DC side, on the negative side, there's no problem. So you don't have to connect any fuse. It's just a direct connection. And during installation, we advise not to connect the Y connector directly to the inverter. Mostly, we suggest to if you make the strings from the mounting system, as long as it will go down or go close to the inverter, make the Y connector not very close or not at the same point where the inverter is, but just before that, like 3 or 4 millimeter away, just in case there will be some misconnection in the system, like this connection or the other connection is not correctly plugged in, because it can happen. This way we can avoid any damages happened. And regarding monitoring and control, as we are an information and communication technology company, we also supply the smart logger, which is a very advanced machine and very advanced communicative device to communicate with the inverter, or to connect in the environmental monitoring system like a weather station, and also the inverter can be controlled, and you can say to the inverter how you should operate, and it can be done via the smart logger. At the moment, the smart logger 3000A and possibly the smart logger 2000 is also available, but the smart logger 3000B will also come. In the past, we have the smart logger 1000A. So the replacement for the 1000A will be the 3000A, and for the 2000, the replacement will be the 3000B. So this is how it correlates. And between the smart logger and the inverter, you can have the monitoring bus communication, which runs through the power line. It runs through the AC cable. You don't have to lay any kind of communication cable next to the AC cable, so there will be no interferences. Or you can also connect via the RS-485 if somebody chooses to, but we recommend to use the monitoring bus. And just an example here, if you have a larger system and you would like to connect these together in one ring, as there is fiber connection for the 2000 and the 3000B, you can connect up to 15 smart loggers into one rings. So that is the maximum. That's the maximum of what the smart logger can operate with. So this should be kept in mind. And also into the smart logger, you can connect, for example, some of the information coming from the transformer station, the transformer protection relay information can be connected to the smart logger via the RS-485, or you can can also connect metering. If you need any metering somewhere, you can connect this directly to the smart logger, or you can also connect the environmental monitoring device, so the weather station, into the smart logger. So by adding the inverter and connecting the set of devices to the smart logger, you will have the option to control and manage via the Netico 1000S. So this is our management system. You can automatically configure the devices when you install and deploy the system. You have real-time monitoring, so you will see what happens in the system with the frequent update. You can also request or remotely download the logs of the inverter in case something happens, because this is what we require during the service process. You can also start the smart IV curve just from the office. So you can diagnose the PV panels, and you can see what happens, what should be done in order to minimize any problem that is on the field. Or you can remotely upgrade the inverters, or you can set some protection parameters inside the inverters remotely. So this is you will have all this option if you connect with smart logger and if you have the Netico 1000s. And just in case you would like to connect to local SCADA or some PPC power plant controller, you will have the option. So we can provide you the Modbus mapping of each inverter that you are using, and you can implement the based on this Modbus mapping into the SCADA system. So you will have the option to see these information coming from the inverters, and you can read it out via the SCADA system, or you can control the inverter with the power plant controller. So it can be also doable. It can be also done, and it is very convenient. A lot of our customers are using it worldwide. So as I mentioned, we have string level management. So you will have live information coming from the inverter. You can set in audio alarms, or you can always look some faults if something happens. But as long as there is no problem, still you can see what is happening for each strings inside the inverter, and this is done by high accuracy data collection with a high precision measurement system. And just a quick introduction. Just a quick introduction about the smart IV curve that I mentioned recently. The smart IV curve system is a diagnosis system which is able to generate or able to measure 128 points of the string curve, or the string IV curve. So it can record the characteristic of the IV curve, and using artificial intelligence and big data, it can compare to the set of information inside the inverter to what kind of characteristics does the IV curve resembles. So this can be done because for each problem, like PID degradation, hotspots, or diode short circuit, each kind of problem has its own unique characteristic. But there are a lot of these characteristics are very similar, but some of them has these. It can be differentiated from each other, but we need to use the help of the artificial intelligence and big data for this. And the smart IV is available also in the 185 KTL inverter, and you just have to use the net ecosystem to run this. It takes approximately one power plant to run this system. It takes 2 minutes to make the diagnosis, and to prepare the report and the operation and maintenance suggestion. It takes around 10 minutes. So by this way, you have a full diagnosis of your system for each string, not just for some samples. For each strings in the system, you will have the report, and you can look for if there is something problem. You can go on the site and check what is the problem. This system is actually also certified by TÜV, so TÜV, and we have the certification that we can diagnose 14 times of module failures. So it is very convenient, so you don't have to go on the site while you see. Just some examples from the world. The smart IV diagnosis is implemented in more than 5 gigawatt of power plants all around the world. Most of the failures are coming from the diode short circuit. So one of the 3 diodes in the system is short circuited, so it causes some abnormal voltage. And also we have some problems with shadings or if the glass breaks. So this is also a common problem. As you can see that we have some project in Chile or in Goldman, China, and we have the failure rate is quite high, so it costs a lot of money to the operators to have this problem. So by this way, by implementing the smart IV curve and to run the test, they can mitigate this factor and they can mitigate the cost and the loss of yield in the operation of the power plant. Okay, so that will be this first introductory webinar for you. I hope it was interesting, and in the next weeks, as my colleague Csaba told you, we will have a separate session for each topic, so we will go into the details. I think for the next week we will have the PV string optimization and calculation. So we will go into the details how it can be optimized for you, and I hope that will be also interesting for you. In case you have any questions, I can answer it right now.